Thank you very much. So let's get straight into today's lesson. This is now from what we call the Free State Assessment Guideline. We call it the FSAG. So the scope of the exam is going to be something like this. But some schools decide to deviate. Yeah? You'll find there's a school that prefers now to have term 1 topics and assess you out of 150. But as a subject advisor, this is what we gave them to say, this is what you need now to set your test based on. So remember, each school now works differently. Each school works in such a way that they want now learners to benefit. So I'm talking to this table such that I want to show you when we set the exams, when we set the test, this is now the framework that we work on. So we are expecting electrostatics now to be 35, quantitative aspects now to be 45. So, but if you check, the total is going to be 100. I sat down thinking, okay, let me do intermolecular forces with you because it's one thing that we haven't done. But I said, let me not confuse you before most of you write now the test. Let me allow you to go and write without us attending to intermolecular forces. The reason for this is I want you now to do the mistakes. Then after the mistakes in a test or the exam that the teachers are going to set, so when we meet, we now close those particular gaps. Hence, the reason for that is the pre-test when we meet in Kronstadt. So we will be focusing on quantitative aspects and now electrostatics. But if you check the two, we did them in detail. I shared all the best strategies that I do have. So I'm expecting you to perform extremely well in questions related to quantitative aspects and chemical change. So we are just going to do few questions of electrostatics and then few questions of quantitative, and then we will be done. That is how you revise. You practice exercises, you try and now close the gaps. So the questions I chose, they address now everything that is on the FSAG. They address everything that is on the quantitative aspects. So depending how fast and quick you are in terms of answering, then we will be able now to complete this particular session. So for once, I'm going to do it differently. I'm going now to give you a lot of time such that you can do the whole question. Then after the whole question is then that we can discuss the question, because I want us to treat it in a form of you sitting down in an exam and you have a question to answer on. So I'm not going to interrupt you until the set given time is over and finished. Is it clear, ladies and gentlemen? Is it clear,
Yes,
ladies?
it is clear, sir.
Thank you very much. So it basically says, I'm just going to give you a question and a timer, then we'll only discuss or share answers once now everything it's done. So let me open the first question. So the first question is on electrostatics. It's 14 marks. So if it's 14 marks, it means you now, I must give you something like 15 minutes. So your 15 minutes will start right about, I am generous, I will give you 16 minutes for that, so that each and every one of us can do that. So start. Thank you very much. That was now the end of the 15 minutes. I only received answers from Jerry. I'm wondering where is everybody else. But if you have your answers by you, no problem at all. I must just emphasize that this was now November 2021 DBE grade 12. So it goes back to what I said. It's a topic that is overlapping to grade 12. So it means now if you are able to do this, because this is now of high standard, definitely you will be in a position of doing well. It says now at question 7.1, a small natural sphere acquires a charge of negative 1,95 multiplied by 10 to power 6 coulombs. 7.11, where the electrons added to or removed from the sphere. This one is very easy to understand. The answer is sitting on the negative value, because we said now for you to have electrons, it means you are now becoming more negative. So if you are now being removed, it means you become now more positive. So the correct answer here is it is added to, because now the sphere is becoming negatively charged. So you become more negative when now the electrons are added now to you. That was now an easy 1 mark. So 7.1.2, it says now calculate the number of electrons which were added or removed. This one becomes easy. We know that N is equals to Q over QE. And now what is the charge? It's negative 1,95 multiplied by 10 to negative 6, divided now by negative 1,6 multiplied by 10 to negative 19. And the final answer there is something like 1,22 multiplied by 10 to the power 13. No SI units, it's just now the number of electrons. So maybe I must change my pen to black so that I can indicate. It will be 1 for the formula, 1 for the substitution of the 2, and then 1 now for the final answer. I hope you guys now still follow. So 7.1.3, it's a definition. Define the term electric field at a point. So we are looking now for key specific weights. So if you do not have this key specific weights, you will be now omitting the 2 marks, because the instruction is clear. For a definition is 2 or 0. So there's no way now we cannot be ensuring that we get the maximum marks. So electric field at the point, it's now the electrostatic force. The electrostatic force experienced per unit positive charge, per unit positive charge placed at that point, placed at that point. And now this becomes your 2 marks. So I must indicate that the key weights that we are looking for, there's somebody here who's making a lot of noise. Thank you, Tato. Okay, I must emphasize the key points here is the electrostatic force per unit positive charge placed now at that point. So those are the key weights that we are looking for. Hence now it must be the 2 marks. Then let's move now to 7.1.4. At 7.1.4, it clearly states that now Calculate the magnitude of the electric field at a point 0.5 from the center of the charged sphere. This one becomes easy. I know we said now once we are given the distance, it's easy. The only equation that I need to consider is KQ now over R squared. So this becomes something like 9 multiplied by 10 to the power 9. And then my charge was given as 1.95 multiplied by 10 to power negative 6 divided now by 0.5. It's in meters squared. And then I get my final answer as 7.02 multiplied by 10 to power 4 Newton per Coulomb. So this is how we mark this one, guys. Be on the lookout for this one. It will definitely be part of the exam because we cannot assess electrostatics without electric field strength. So it will be one for the formula, and then one for the whole substitution, and 1 mark for the correct answer with the correct SI unit. So if your SI unit is wrong, automatically now you will not be getting it right. So let's look into 7.2. 7.2, they say now 2-point charges Q1 and Q2 are fixed 0.02 meters apart. The magnitude of charge 1, Q1 and Q2 is the same charge, and Q1 it's negatively charged. The small charge sphere is now of negative 1.95 multiplied by 10 to the negative 6 is placed at the point 0.03 meters east of charge Q2, as shown in the diagram below. The sphere at point P experiences now the net electrostatic force. So what are we given here? We are given the net electrostatic force. Before we can do anything else, this one will be easy to do or to understand if now we are able to draw a free body diagram. They say here, calculate the magnitude of the charge on Q2. So it says we need now to calculate the charge of Q2. So basically, Q2 in this case becomes our reference point. And we are told also that the net electric static force is 1.8,3 newtons west. But because of they have the same charge, obviously it's repulsion, so they will be moving in opposite directions. So I'm not going to draw that for you, because now we will be in a position of saying at 7.2, we have F net, which is equals to F now of Q2 plus now F of Q1. And this is easy. We know F net is 1.38 to the west. And we know that we can easily say KQ1, Q2 over R squared plus and minus, because the other one is going to be negative, and now R squared there. Remember, the negative is from the free body diagram. So for the purpose of the time, I'm not going to go into detail. You'll check because you'll still get the notes there off. So what is left here is just substitution, 10 power 9, and then Q1, we are told it's the same charge as the above, multiplied by 10 to power negative 6. And then Q2, what is the distance now between the two is 0.03 squared, plus now 9 multiply negative, remember, 10 to power negative 6 multiplied by Q1, which is 1.95 multiplied by 10 to power minus 6, and you still have your Q2 divided now by 0.05 squared, and then you do your mathematics, you will eventually find Q2 as 1.1 multiplied by 10 to negative 7 coulombs. That will be now your final answer. I'm just sharing the approach. Kindly follow through. Then it basically says what is key, or the best way of doing this one was for you now understanding this particular step here. This step is key because now you can only understand it fully if now you draw a free body diagram. So I'm going to write it here for you to be able to remember, to say the highlight here was now draw a free body diagram. If you do not have now a free body diagram, it is going to be a big challenge. So these are the answers. You can check me on them, but I believe I am on the right track. So this question, if you check, it addresses the electric field. It also now addresses Coulomb's law. So those are the key things and the reason why I chose this specific question. If you have questions, I'm going to open up for the next 10, 15 seconds. Then I will know that, okay, let me make it 20 seconds. Then if there are no questions thereafter, I will try to move to the second question of the day. Thank you very much. I didn't get anything from the chat. I didn't get anything or hand raised. So it basically says, let's move on now to this one. So this one is 10 marks. It means I must give you something like 7 minutes for you to complete. So let me add a timer. Then we make it now 7 minutes for you to be able to complete. Thank you very much. Our time it's up. Thanks to Mbelempo and Sibusiso Makoba. All your answers are correct. Sibusiso, you don't have 5.5, but everything seems to be okay. Thank you, thank you, thank you. Let me try to explain it quickly so that now we can move to another one. It says here, a learner adds an excess hydrochloric acid. Take it down a little bit. Excess hydrochloric acid. So we know now that hydrochloric acid already is in excess through the to calcium carbonate grains. The concentration of hydrochloric acid is 0.1 mole per decimeter cubed. And the volume added now it's 500 centimeter cubed. The reaction takes place is represented by the following reaction. The carbon dioxide gas formed fills a large gas cylinder or syringe. The volume of a gas collected is measured every 30 seconds, and then the results are shown in the graph below. So this is the graph. And now the best thing that I usually say now, what is this straight line basically saying to me? It says now the reaction is complete. The reaction is now complete. So because of this, it allows me already to know when it started now to approach completion, not equilibrium, but to be complete. And I did explain this in one of our lessons previously. So 5.1.1, how long did it take for the reaction to be complete? We can see it started normalizing now here at 120 seconds. So the correct answer here should be 120 seconds. So you get 1 mark for that. It's easy to see. And then determine the volume of carbon dioxide gas that is formed. So we use now this to get the volume. We can say it's plus minus 250, but it's directly 250. So it will be easy to say it is 250 centimeter cubed. If you do not have the SI unit, we don't give you a mark thereof. Which substance is a limiting reagent? This one was easy because we are told that hydrochloric acid is in excess, so we are only left with calcium carbonate. So this was now an easy thing to do. So let's get to 5.17. This is where now the 7 marks is. Calculate the mass of calcium carbonate grain used in the experiment. The carbon dioxide gas collected in the syringe is at the temperature of 25 degrees and is at now standard pressure. So what does it basically say here? It basically says I am working now with the STP values. So if I'm working with the STP values, it basically says 5.14. What is it that I have? I have the volume of the gas collected, which was now 250 centimeter cubed, which is just now 0.25 decimeter cubed, because we said we always want our volume to be in decimeter cubed. What else do I know now about the STP volume? I know that the volume is 22.4 decimeter cubed. Then it basically says, I can say now the volume of a gas now, which is carbon dioxide, will be 0, let me write the formula first. That is always important for the purpose of marking. Then I will say now I have V over Vm, which is just now 0.25 divided by 22,4, which will give now my answer as, let me quickly get my calculator, something like 0,01 mole. But now these are the number of moles of carbon dioxide. So what must I do? I must now relate now the given with the unknown. What is it that I can use? I must use now the molar ratio between the two. That is the complex stoichiometry calculation that we spoke about. So I must be able to say number of moles of carbon dioxide should be equals to the number of calcium carbonate because the ratio now is 1:1. So we can easily say the number of calcium carbonate moles will also be 0,01 mole. So once I have the number of moles, it becomes easy because now I can say the number of moles of calcium carbonate will be just now 0,01, and I want the mass. What is the molar mass of calcium carbonate? Is something like 40 plus 12 plus 16 multiply now by 3. Then you do the mathematics, you'll find that M is something like 1,12 grams. I see Manuku, your hand is up, so I'm going to try and allow you to ask your question. Manuku?
Sir, can you
Yes,
explain again? Can you explain again from 5.1.3 until
5.1.3.
5.1, both
Okay.
5.1.3 and 5.1.4?
Okay, Manuku, thank you. 5.13, from the statement already, a learner adds excess hydrochloric acid. Let me highlight it to say now they are telling us that hydrochloric acid is in excess. So obviously, if we check this reaction here, is the reaction of HCl and calcium carbonate. So if the other one now is in excess, which is HCl, it says now this one must be our limiting reactant. Because remember, in every reaction, you always have a limiting reactant and the one that is now in excess. So this answering this one of 5.13 was easy, hence it is 1 mark, because we didn't have to calculate, we didn't have to do anything, we just needed now to reason from the statement that is giving. So if HCl is in excess, calcium carbonate is a limiting reactant. Fine. Now calculating for 5.14, let's read the question again and highlight now a few things. It says now, calculate the mass of calcium carbonate grains. So we are calculating the mass. The carbon dioxide gas collected in the syringe is collected now at the temperature of 25 and is at standard now pressure. So the conditions of STP, we said now we want our temperature to be now at 25 degrees. We said also our pressure must be 1 atmosphere or 101,13 kilopascal. So, but we are told this is now at STP. What did we say about STP? We said now it gives us a platform of using the molar volume of a gas, which is now 22,4 decimeter cubed. Let me change and write with a pen, not with a highlighter. So because of that, we know that temperature is given, then we'll say pressure at STP. If you remember well, we said it is 1 atmosphere, which is equals to 101,13 kilopascal. These were the conditions: temperature 25, pressure 101,1, and then we said now volume of a gas or molar volume of a gas will be 22,4 decimeter cubed. So already it says now I am in a position of going there and say I am given the volume that was collected from this answer, which was now 250. But that 250, it's now in centimeter cubed when we check the SI unit on our y-axis. So it basically says this one I must now convert to decimeter cube. That is the reason why we converted now to decimeter cube. But what is it that I know? We said now the only way of relating the carbon dioxide with the information that is given with the unknown is through the number of moles. We only compare moles with moles. So with moles, it says now to me, I must calculate the number of moles of carbon dioxide using N is equals to V over Vm because I have the volume, which is 0.25. I have the molar gas volume, which is 22,4, and now I can get the number of moles. But the only way of me now relating the given information and what is being asked, it is now what? Using the molar ratio. So here basically it's us using molar ratio. Then once I have the number of moles, the only way of me now relating the number of moles with mass is now through this particular equation. Then I have my number of moles. I can calculate my molar mass and then make mass subject of the formula. Then I'm in a position of getting it correct 100%. So let's see how they allocate marks such that we know how they mark in an exam. It's going to be 1 for the formula, 1 for the substitution, 1 for the final answer, 1 for molar ratio, and 1 for this formula, 1 for molar mass, and then 1 now for the final answer, and then it becomes your 7 marks. I hope it's clear, Manuku, and everybody else.
Yes, sir.
Thank you very
Yes,
much.
sir.
Mr. Villagazi, sir, Marshall.
Yeah, good day, sir. Good evening.
Evening, sir.
Yeah, I was going to ask you about running off. Or if there's one thing I realized about stoichiometric calculations is one thing that's going to make our answers different is when it comes to rounding off. I mean, some of us round off to 2 decimal places and some to 3 decimal places. So how would you advise us to be more accurate when it comes to writing exams?
Okay. The advice I can give you, Your Excellency, Mr. Marshall, is you see in the intermediary steps, like for instance, where I divide 0.25 with 2,4, that answer must be maybe a maximum of 5 digits after the comma. And the one that I'm going to use here must be now 5 after the comma. But the final answer is the one that I'm going to round off to 2 decimal places. So you don't round off within the intermediary steps. You only round off at the final answer. So the advice that I can give to everybody in here is that don't round off in the middle of the steps. You only round off at your final answer. So for instance, let me take my calculator quickly. I have a calculator here.
No.
Let me check. I think you can see my calculator as well.
Yes.
0.25 divided now by 22.4. And then that's the answer. You see, so it says now 0.0111607. So it means I must now be able to take 0.111 up to 6. Then is the only number that I am going to use. I can only round off at my final answer. Yes. So the easiest way is round off only at the final answer. Within the other steps, don't round off.
So we have to go up to 5 decimal places.
Yes, but now that is during the intermediary steps. So final step, because the instruction of the examiner in the final step is round off to 2 decimal places. So such that such that now your answer is not influenced by the commas at the top, go up to a maximum of 5.
Understood, sir.
Thank you very much, Your Excellency, Mr. Marshall Villagas. Any other one? I'm setting a timer for that. Disciplines, mini tools. I'm setting a 15 seconds timer. If there are no questions, then we can move to the other one. Thank you very much. I hope everything is clear. Then let's quickly try question 6. I don't think we'll be able to get to question 7, but let's see if we can go with 6. 6 is 8 minutes. So it's 8 marks. It basically says I must give you 6 minutes. I must give you 6 minutes to do this one. So let's go. Question 6 only. Thank you very much. I hope everybody tried their best. I got few answers and they look to be correct. Let me check this one now from Lucky Machinini. I think that's for 6.1. That looks correct. No, thank you very much, guys. Let me quickly explain then 6.1. So with 6.1, the catch here was a nitrogen and oxygen composition. So it means in a reaction vessel, we have a mixture of nitrogen and oxygen. But that mixture, sorry, has now a total of 4.6 grams. So it basically says to me, I must be in a position of now finding then the mass of oxygen, because I am given the mass of oxygen. I must be now looking for the mass of nitrogen thereof. So for me to do that, it's now the mass of nitrogen is equals to the total, which is 4.6 minus now 3.2. This will be equals to 1.4 grams. The reason for this is with empirical formula, I always now work with mass and the number of moles. So I need now to use this to get the number of moles of nitrogen. So it will be 1.4 divided now by molar mass, which is 14. This will be equals to 0.1 mole. Then I need to have now the number of moles of oxygen. This will be the number of moles of oxygen. This will be now 3.2 divided by the molar mass, which is 16. Then this is equals to 0.2. And then I do now the molar ratio, which is that into the number of moles of oxygen, divide now by the smallest number. This is 0.1. This is now 0.2. Divide by 0.1, divide by 0.1. You get now, this is just 1, this is just 2. So our empirical formula will therefore be NO2. And then this is now an easy 4 marks. But what makes it more complex was now us finding the number of the mass of nitrogen. Then we get a mark also for calculating the mole and then using the molar ratio, and obviously the final answer. This will give us now 4 out of 4. Let's quickly go to 6.2. So with 6.2, the catch here was, if it is known that 46 grams of a gas at STP occupies 11.2 decimeter cubed, calculate the molecular compound of the formula, or the molecular formula of the compound. So what does this say? This says now I must now be in a position of calculating the molar mass. After getting now the molar mass, divide that molar mass so that I can get a constant between the two. So I'm going to do it in quick, simple steps. This one is just for me to find what is the number of moles that produced the 11.2. So I'm going to just say gas, which is gas X, because I don't know. Let me just say just gas. This will be V now over Vm. It is at STP, so I can confidently say 11.2 divided by 22.4. This is equals to 0.5 mole. But if 0.5 mole produces now 40 6 grams of a gas, what will 1 mole produce? Because remember at STP, we say it is going to be 1 mole of a gas. So it basically says if I use now 1 mole of a gas, it must produce now 2 times more, and 2 times more must be now 92 grams. So if this is the case, then I can easily be in a position of saying the molar mass now of NO2 is 46 grams per mole. And now I want to know the molar mass of X. So the molar mass of X in this case must be just now what? Must be 92. So we divide now this, and then we get a constant, a multiplier, which is just now 2. Then our formula will be NO2, O2, then we get our final answer. So I used ratios. There's an easier way of doing it, but now I felt like, let me show you a simpler and easier way of doing it. So on my watch is exactly 8:30, 20:30. So I'm going to allow you to ask questions for the next 2 minutes, and then I will close the session and remind you now again for the camp. And I feel that we don't need another lesson thereof. So this will be our last lesson until we meet next week at Crew on Start. So Jerry, let me start with you while the time is ticking.
So
Yes.
for molecular formula, was not supposed to be N2O4.
N2O4. I didn't multiply there. Ne? Yes, it is correct. Sorry. I didn't multiply with 2 there. Thank you, Jerry. It must be NO2O4. Thank you. And then wait, let me check who else's hand is up. Marshal Villagas, Your Excellency.
Yes, sir.
Yes, sir.
Yeah, my last question is when it comes to electrostatics, like how much percentage is it going to be composed in the test? I mean, considering the fact that we've been writing exams, so I haven't been very attentive to electrostatics, or should I say physics.
Okay.
So it's about like I say.
Okay. Check your screen. So if you are checking your screen, that is now the totals in the test. So it's going to be 35% in simple English. But now that's if your school follows this guideline, because this is now a Free State guideline for everybody. But like I said, because the test is being set at the school level, a school can somehow now manipulate the system. And let's say, for instance, other schools manage to ask intermolecular forces in term 1. They can now add electricity, quantitative aspects, and electrostatics. But now this is the framework that we're supposed to be working with. I hope it's clear, Your Excellency. Yes, this is the framework. So you have tonight to sit down and try look into it in detail. Thank you very much. Any other question?
One last one, say.
Oh, okay, Your Excellency.
Yeah. So I was going to ask you again concerning the method we use to like calculate stoichiometric calculations, like body moles and all that. I realized that Miss Ali or Mrs. Ali's method is more faster. Would our max still be awarded if we used her method, like the table method she does?
We have options in the paper, ne? So, and we have bullets that we use to mark. For instance, let me try to share a different screen quickly, ne? Let me try to share a different screen quickly. I don't have it here, unfortunately. There will always be, let me close this. There will always be bullets, especially, let me go to this one of 7 marks stoichiometry. Yes, you see this one of 7 marks, 5.14, ne? We are going to have 7 bullets. Let me make them here. 1, 2, 3, 4, 5, 6, 7 bullets. So with these 7 bullets, it's a guideline of what we are looking for. The bullet number 1 will say the learner used N is equals to VM. We give a mark. Ne? The learner now used or divided 0.25 with 22.4. We give a mark. Then the learner got the final answer 0.1. We give a mark. Learner used Molar ratio 1:1. You see, learner now has the number of moles this equation, we give another 1. The learner now substituted 100 grams per mole into this equation. The last one is the final answer, correct. You see, so these bullets are the bullets that we are looking for. So if you use the method of Ali, it's going to be a challenge if all these bullets are not there. Yes, it's quicker, but it's the university science. So remember, we make it easy for our teachers as well, for them to be able to mark and not disadvantage the learners. So if you use that, I think you'll only be getting the correct answer, but you'll get a maximum of 4 out of 5, if I remember well. So the 2 marks or the 3 marks you are going to lose because of, if you remember well, that method is the method of ratios, ne?
Yes.
Yes, so it does not follow the marking guideline or the sequence that we are looking for. That is now the set part. It's a good method when the time is against you. It will give you a maximum of 4. But now if you follow the sequence, then I believe everything will be fine. Because now we are looking for a formula. Did you substitute into the formula? So it gets complex at times. But we do accept that method. So if you write that method, just be aware that other information is going to be omitted. Then we'll only give you 4 out of 7. And then you ask, why are you not getting level 7, level 8?
All right.
All right. Thank you. Any other one? Or do you still have another one, Mr. Masha?
No, sir. I'm satisfied.
Okay. No, thank you very much. Any other questions? Okay, if there are no questions, then from me to Ntabisen Shabalala.
Good evening, sir.
Good evening, Ntabi.
Sir, I was asking regarding the transport. You said for schools like into the coordinator will be communicating regarding the transport with us. Is it with us or the principal?
Hence, I said check with the principal first if they haven't received any mail related to that. Ne? If they don't have, quickly tell me, then I know who's the coordinator that side, so that you can be assisted very, very quickly.
Okay, thank you, sir.
Thank you. Kindly check with the principal because the message was sent to the principals.
All right, thank you.
Thank you. Jerry?
As the last question that we have just done right now,
Yes.
teacher, I can understand.
Okay. Where don't you understand, Jerry? You don't understand this ratio of the number of moles and STP, ne?
6.2, sir.
Yeah,
Yeah.
6.2. Okay,
Yes.
let's read the question again. It is known that 46 grams of standard gas at STP occupies 11,2 decimeter cubed. Ne? But we don't know what gas is that. So we want to know how many moles. Remember, for me to compare, I need to have the number of moles. Hence, I said stoichiometric calculation is the number of moles. So what is it that I have? I am told it is STP. I have the volume. So at STP, I know I can use the molar volume of a gas. Ne? But now this is gas X. I don't know what is this gas. So if this gas now produces 0.5 mole, I want to know, because for me to relate another gas, it says it must be in 1 mole of 22,4. So this ratio here, if I'm producing 46 grams from the 0.5, which was given there, it basically says now with 1 mole, I must be now producing 2 times more, which is now 46 plus 46, it will give you 92. Now, here comes the trick. The 46 grams, it's now directly converted to molar mass. Because remember, for us to get this particular constant, we divide molar mass with now what? Molar mass. So let's check if that is true. What is the molar mass of nitrogen dioxide? Let's see if we get that answer. We say now it is going to be molar mass. We say it's going to be the molar mass of nitrogen dioxide. What is it going to be? Is it going to be, I don't have my periodic table here. What is the molar mass of, kindly check for me. What is the molar mass of nitrogen? Is it 14?
Yes, sir.
14, eh?
Yes, sir.
So 14 plus 2 multiplied by 16. So this is 14 plus 32. This now gives us 36. 46. 46 grams per mole. But remember, we are using this now from where? From the information that is given that the 0.5 is going to produce this one, but the 0.5 is producing now 46 grams per mole. Yes, it was Jerry. Before I continue, do you understand so far?
Teacher, a little bit that it's actually one. Thank you, sir.
Okay, but now the key thing is at now the 46 grams that is produced from nitrogen dioxide. Ne? But nitrogen dioxide is giving us 0.5 moles at now the volume of 11.2 decimeter cubed. But what is the rule of standard temperature pressure? Is that 1 mole? We work now with 1 mole. For us to use the 22,4, it must be for 1 mole. I just wish I had that presentation here that said it must be 1 mole of a gas that occupies that particular problem. Let me check quickly. It's not going to assist now because I must save this one first. Jerry, kindly look into it. If you have challenges, feel free to contact me. I will be in a position of explaining it further.